Let's quickly go over problems from chapter number 2. At the end of chapter number 2, these are the problems that you will have to do for the homework. You will have to use the figure 2.4 where we observe curves between H and B, and using that, and there is an example also given, the relative permeability of steel and iron. So it will be straightforward once you do it. Likewise, the second is pretty straightforward. You have to apply the Faraday's law of electromagnetic induction, dphi over dt, n times dphi over dt, to find the magnitude of the induced voltage in the coil. The third one again is pretty L dot V cross B to find the induced voltage in the coil. The fourth one is about the Lorentz force. The fifth one, however, I'm going to go ahead and discuss it. I mean, if I put this problem in chapter 3, it's going to be easily understandable, but since we have not discussed this, let me go ahead and discuss it. So in this, observe what's going on. You have a loop, this, which is moving, rotating about this axis, which is in the center, and it is rotating in, let's see, clockwise direction or counterclockwise direction. So it is rotating in counterclockwise direction about this axis, so rotating in this direction. Question is, what is the voltage, and the B is this is your XYZ right here. So observe B is in the direction of y-axis, positive y-axis, and the velocity, it is doing counterclockwise. So at this specific instant of time, the velocity vector on this side is going up, and velocity vector on this side is going down. So the velocity vector here on this half of your coil or conductor is going up in the z direction or k direction, and velocity vector on the other half of the axis around which it is moving is going down. So B is in the y direction, velocity vector here is up, velocity vector here is down, and this is your coil. So this length from B to, I don't know, you can call it C, you can call it D. So from B to C is along x-axis, then CD is along y-axis, and then DA is along x-axis again. So the question that I'm asking is, how much voltage will be induced at that instant of time? And you have to use, of course, V cross B dot L or L dot V cross B. Velocity is given to you 2 meter per second, and value of B is given to you 2 Weber per meter square. Length is given to you 1 meter here, 1 meter here, 0.7 meter on side D and C. How are you going to solve this problem? Basically, you're going to calculate the induced voltage on each side separately, and then you're going to add all of them together. So I'll give you an example, B and C. So L dot V cross B, right, on side B and C. Let's assume the current is going to flow into the page, that is from B towards side C, right? So let's assume that induced voltage direction is this, plus here, minus here. Okay, so that means length vector is going to be in negative I direction. So 1 negative I. If you want to, you can assume it coming out. So B is positive, C is negative. In that case, it's going to be 1I, irrespective, as we discussed earlier. And V cross B. Now at this time, this side BC has a velocity vector which is going in the positive z direction, and the velocity value was given to you, well, was 2 meter per second. Yeah, 2 meter per second. So velocity vector is 2 meter per second in the direction of positive z, and the B vector is constant, it is in the y direction, 2 Weber per meter square, so 2 times J. So when you calculate this, what you're gonna get? K times J. So Kj means you're going counterclockwise. that's gonna give you negative I. So negative 4I, and then you have negative 1I dot negative 4I. So you're gonna get 4 volt, right? And this is a positive voltage. That means our assumed direction of current going from B to C is correct. So this induced voltage on this side is gonna be 4 volt right here, right? Likewise, you're going to calculate the voltage on side D and C and calculate voltage on side D and A. You're gonna add all of them together and you will have the total voltage. So think about it. I don't want to solve the whole problem for you. Think about it. Gave you a hint. Sit down, think about it, and even if your answer isn't correct, but spend some time, think about it. Even if your answer isn't correct, as long as you're working, you're not going to lose point in the homework, and eventually you're going to learn how to do it. But think about it, how to do it, and it's going to be it's not hard. You will understand it easily.